Welcome back to the VTC video training course on C++ fundamentals. We're going to talk about constructors for a few minutes here. The constructor is a special function that is called whenever you create an object of a certain class type, or you instantiate the class, and that's what actually makes an object in memory and causes it to come alive and do things. Well, the first thing that it wants to do is if it needs memory or needs to initialize some variables, things like that, those things need to get done in the constructor function. The compiler will provide an empty constructor if you don't give one yourself in the class. You probably, though, in more complicated classes, will want to provide your own constructor so that you know what's going to happen when somebody makes an instance of your object. We'll talk about destructors later, and they're going to serve cleanup duty. The constructor has the same name as the class. The function name is exactly the same as the class. We're going to see an example here in just a second. The constructor, again, creates all the variables, allocates any memory, opens connections, whatever you need it to do for this class object to be able to function. Now, a constructor never returns anything, and it has no return type, not even void. So nothing will ever come back out of a constructor, just so we know that. Here's an example of our little class again called cfoo. And remember, we just have a capital C in front of it just to denote that this is a tag for a class. It's the name of a class. And we're not actually creating anything here. This is just like our old struct definition. Everything's going to be public now in this class because we set a public access specifier. And there's an integer I and a character C. And this is our constructor because it has the same name as the class. So that's cfoo, and it will require an integer and a character. Now notice that this is just the declaration of the constructor, of the function. This is a function declaration. We haven't defined it anywhere on this page or in this translation unit. Somewhere there will have to be an actual function with open and closed braces that does something with the integer and character that come in. This is simply telling the compiler that when a class cfoo is created, instantiated, an integer and a character must be provided to the program so that things can be set properly. In our case, I and C would have values put in them. So down here, we're going to use cfoo, our little type now that we created, and make a cfoo class object, just like we did in a previous example, and we'll pass in an integer, just the number 1, and a single character. This is good. This will work, and it will make one of these objects, and it will put an integer and a character in it and load them appropriately. This is wrong because we are creating another cfoo, same class, trying to create another object, but we're not giving what we told the compiler has to be in here. We're not giving an integer and a character to the program when we create this thing. And that's one of the gems of C++ is that it will help protect you from doing things like this. Now obviously this is right next to where we created the class, so you'd think we could look up there and figure out that we need an integer and a character. But imagine if this is several files away or a continent away if somebody else is writing using the cfoo classes and they're not sure what is supposed to be handed in here. Well, when it gets all compiled and linked together, the program is going to tell them that this is not right, that they need this integer and character in there. Let's take a look at what we need to fix that and make that work somewhat. We need a default constructor. A default constructor doesn't take any parameters into it, and then we can work with that. We can resolve it some way in our program and maybe set some default values for our integer and character, and then someone else using the class doesn't trip over it. They don't have to worry about that integer and character coming in. Now if you want them, of course, to have to give you an int and a character or whatever other initialization type parameters, well then don't worry about the default constructor. Let the program find the problem, and the compiler and linker find the problem and tell them about it right up front. But if you want to be able to create this class object without any parameters, here's where you do it. This is called overloading of this function. And overloading means that we create another function declaration here with different parameters. This one has no parameters. So when we come down here and create a cfoo, another cfoo object with no parameters, the compiler will do a lookup. And it will look at this and go, well, that needs an integer and characters. Does that match? No, that's not going to work. That's the constructor that it used when it created this object, though. But when it goes to create this object, another cfoo with no parameters, it goes through this list and says, oh, there's a constructor I can use, so it doesn't throw an error. And of course, we would also have to someplace define the cfoo function that does not have parameters, and maybe we would set these to initial values, the integer and character. We would do something to clean up properly and make sure that everything was still working. All right, so that's a constructor and what it does, and a default constructor. And we're going to keep on moving on and look at some other kinds of constructors. Hi, and welcome back to C++ Fundamentals. VTC video training. We are going to take a look at something called copy constructors and copy assignment operators. These are special constructors that are used when we copy classes or we initialize a class by setting it equal to another class of the same type. All right, we have two different situations here. In the copy constructor, this is going to get called when a new class object is initialized using an existing class object of the same type. Right? That's our first rule that gets us into a copy constructor. Now, if you don't provide a copy constructor, one will be provided for you, and it will perform a shallow copy by value. The values that are in the variables that are members of the class will be transferred one to the other. The trouble is, if you get any kind of a useful class going, you're going to have pointers, you're going to have pieces of memory that you've created in there, new arrays, memory allocations, things like that, and a simple copy by value will not get it. It will not move the things that you want, and sometimes it will move values from the source object into your destination object when you really, in the destination object, need to create brand new elements, new names, or new strings of information, and not just take a pointer to the data that's already in another class. So when you get into that kind of a situation, you need to have a copy constructor because you need a deeper copy of the variables, and you may have to have new objects initialized during the copy. Here's what a copy constructor declaration looks like. Here we have our normal constructor that we created. Here's a copy constructor. Notice that if the class cfoo is created or is constructed and is given a reference to itself, to another instance of itself, that's what this reference is. This is just the name of it over here. If that comes in as the input, our copy constructor function is going to get called. So here we create a cfoo class object of type cfoo. We already know that, 1 and a, no big deal, that's what we've done. Here we create another cfoo, there's the class, but we are initializing it with the existing acfoo class object that has the 1 and the a in it. All right, that's being passed in. So the compiler is going to see that it should use this copy constructor. And then we simply have a function that is cfoo double colons cfoo. It's yet another constructor, and it has this same kind of a reference here for cfoo. And we put in the simple, basically C code that will perform the assignment that we need to perform, that will get the integer, in this case very simple, the integer and the character out of the source, the acfoo class object. In our case, we'll get it out of here and put those values into the data points of this new another CFU that has just been created here. So that's a copy constructor, and this is what the declaration of the copy constructor looks like. Now, a copy assignment operator. This is the function that is called when a class is copied one into the other by using the equals, the assignment operator. Again, the compiler will provide a shallow copy if you don't specify one, but same reasons, you may need a more full function copy by assignment. Here's what this one looks like. Here's our other constructor. That's the same, but this is our new line. Here we have a CFU. We're referring to the operator. So we use the word operator and then which operator, and that's the equals. So we have a CFU operator equals, and then the CFU reference is what will be passed in. And so we are redefining or overloading this operator and declaring a copy assignment operator. Then down here, this is how it gets used. Another CFU equals a CFU class object, so that's a copy assignment. We have created a new another CFU by this type, by declaring it here, and we have initialized it with the already existing class object from up here that we created with the 1 and the A. So when the compiler sees this equal sign being used with the same class on either side, it will understand to go find this function that we will have defined that says exactly how to move these members of the CFU class, whatever they happen to be. And if new strings, new buffers, something has to be created, then that new reassignment of that operator function can take care of those things. Okay, so that's the copy assignment operator and the copy constructors that we needed to have some information about. Hi, and welcome back to VTC's C++ Programming Fundamentals. We've been talking about various types of constructors here for a while, and now we want to talk about destructors. The destructors are the members of the class that takes care of cleanup when the class is no longer necessary and when objects in the class need to be gotten rid of. Now, there are destructors for everything, though you don't really have to deal with them. All of the base objects that are in the language have destructors for them, so that when you delete them or when an automatic goes out of scope, you know that it disappears, it gets pulled off the stack, it gets destroyed somehow. Well, a destructor is always responsible for doing that. When we create our own classes, though, we need to create sometimes our own destructors, because we might do interesting things in the construction of an object that has to be properly taken care of during the destruction of the object. We might get some file tokens open or locks, or we might acquire some memory in an array or something like that, and we need to properly clean that up. And we're the ones that created it, so we're the only ones that really know how to get rid of it. So again, the destructor is the function that is called when a class is no longer needed, or when that class object goes out of scope and it's no longer necessary to be in memory. Of course, when the entire program ends, anything that is still in scope and still functioning will have its destructors called so that it's gotten rid of. The destructor is identified by the tilde in front of the class name, so that makes it the complement to the constructor, because as you know from C programming, the tilde in the front there is the one's complement. So this is a complement to a constructor, a destructor. There is only one destructor for each class. It cannot take in any arguments, and it cannot give back any return values, because everything that it's doing is destroying things and throwing them away. So it has no structure to use to get anything back to you. Again, it cleans up everything created by the constructor. Now, you want to make sure that you don't exit while you're exiting, because when you're in a destructor, you're leaving the functionality of that object. You're getting rid of that object. So if you would call exit in there, exit by its definition calls the destructors. Well, now you're back in the destructor, and then you call exit again, and you're back in the destructor. See what's going to happen? You're going to wind up in a tight little loop there and get stuck. So just be careful that you don't do that on the way out. Let's take a look at a sample destructor here. This is pretty much our same little stub program that we looked at before, and it's when we were talking about constructors. And here we're going to have a class with a name, and here it's going to have the S character pointer in it, and a lot of other things will be created in here. So that's our name class. Now we have a table class, And a table class will have a name pointer to, so now we know that we have a pointer to one or more of these classes up here. And here we have a little SZ that's the size, and that's, you're going to see that's the size of how many of these P pointers are actually out there. And here's our access descriptor for public. Says that this is publicly accessible. Below, this was private up here. So here's our table, and our default will be 15 elements in the table. It will be passed in to S. And here is the constructor for the table class. It's inline, so it's right there in the code. It's our open and closed brace. Remember, we can do that. Here we say that our pointer is equal to a new name array of this SZ size. And the S we know is 15 by default, unless somebody creates a table of a different size and they pass in a different value. If they don't pass us a value, we'll use this 15 for our default. So this is, in this constructor, it's doing something a little different, a little something interesting by creating this array. So we need to have the destructor understand that and know how to get rid of this thing when table is no longer in scope, when table can be thrown out. So there's our one's complement, or our little tilde, to show that this is the destructor name. And remember, that was a constructor. It's the same name as the class. And here we have the same name as the class again, but with the tilde in front of it. This is our destructor. Again, it is an inline declaration and definition of this function, and all it's going to do is a one-liner delete of this array known as P. So that will go through and get rid of those objects that were created up here during construction. Now, who knows what we've been doing all the time with this thing after it got created, but now, as we're getting rid of it, as table is being deleted, C++ understands that it must do this delete function. And there's a couple of other functions in here. There's a name lookup that's a public member of the table class, so that somebody could look up something in the table. And here's another one that's an insert, and they could put things into the table, and we'd probably have something else where they could delete things out of the table, but we don't care about that. This is what we're after right here. So that's the function of the destructor, is to get rid of the things that you created with the constructor. Very simple. Welcome back to the VTC C++ fundamentals. We want to take just a minute to talk about order of initialization. This is important for you to start to understand even in the fundamentals, because of the way the compiler operates and the way it creates the base classes and any derived classes that you create off of those, derived from those base classes. If you don't understand the concept that one thing will be created before another, you can make the mistake of trying to use an item that is not yet initialized, and that can certainly be a problem. In the order of initialization, first the base class constructors are invoked, and they are invoked in the order of their declaration. So that's important to know when you're creating base classes or using them. They must be declared in an order that you will be using them as you derive from them and as you initialize them. And we're going to take a look at a piece of code here in just a second to reinforce this. After the base classes are constructed, then your member object constructors, if you've created any, are invoked in the order of their declaration. So first base classes, then member object constructors, and then finally the derived class constructors will be invoked. So that the bases have already been created so that we can then derive from them. Now, of course, we know that destructor invocation has to work in the opposite order, because you can imagine these things are stacking A, B, and C on top of each other. So we have to destruct or destroy the last one created. So the derived class destructors are called before the member object destructors are invoked, and they are in the reverse order of their declaration, so we're working backwards off of what was created. And then finally the base class destructors are called in their reverse order of declaration, so we get back to basically an empty memory structure. So obviously the order of invocation of destructors is the reverse of that of the constructors. Now let's take a look here at a little piece of code. Here's a way that you don't want to initialize and a way that you do. Let's say that we have a shape class, and this is the shape constructor. We'll have a constant point center up here, and then a color will come in, and then you might just want to go ahead and say that here you have these objects or members inside the shape class, and you set them equal to the items that come in. Well, what happens when you do this, when you reference center like this, you cause another call to the constructor of point to get this value, and then you have to do an assignment. What you want to do is an initialization, and that's what we have down here. Here we have the constant point center, the end color, just the same way, but now we use a colon after this closing paren and say that our local member is center, and it should take this value into it, and our local color should pick up this color. So now the initialization has been performed without an extra call to the constructor of point, and we don't have to do any assignment down here because the copy constructor is going to be used down here rather than the assignment constructor that would have been set up this way. So it's more efficient, it's faster, and when you get into creating so many classes and the way that they come and go, especially when they're automatics, that happens so often and so quickly that anywhere that you can save a few cycles is going to make your program that much more efficient. So that's what we wanted to talk about, the order of declaration, construction, and destruction. Hi, this is Tim. Welcome back to the C++ Fundamentals VTC video training course. We're going to talk about user-defined conversion. Now, you already know about automatic conversion of types like integers to floats, floats to doubles, characters to integers, things like that happen implicitly and are performed by the compiler so that the correct work can be performed. If you multiply a character by an integer, we're going to promote the character, cast it up to an int, and then perform the work. Well, a user-defined conversion is when the compiler has no idea how to convert something to something else. Most specifically, how to convert a type to an object, and that's what we're going to do. The user-defined conversion lets you specify how an object converts either with constructors or with a conversion function. The user-defined conversions are implicitly used. They're not called like a cast would be. They are just used when they are used in code. And of course, we'll look at some code here in just a second to back this up and show you what I'm talking about. They're implicitly used in addition to standard conversions to convert initializers, function arguments, function return values, expression operands, expressions controlling iteration like in a looping environment, selections, and explicit type conversions. Now, like I said, there are two types of user-defined conversions. There's conversion by constructor, and then there's the use of a special conversion function, and we're going to look at both of those. Now, here's a converting constructor, and you can see this constructor is right over here, that we have a class Y, and here we have a converting constructor that has no code in it, neither one of these two. So if a integer I is passed in, we would return Y, and that would perform that conversion for us. And here this one takes a character pointer in and an integer and returns Y back. Then of course there's just another little method down here called add to do whatever it's going to do. That's just part of our class definition. So here, over here in main, we're going to be using this class, and just consider that this went on in one long list. I just can't show it to you on the screen in one long list. So here, y of object 1 equal to 2 is the same thing as making object 1 equal to y initialized with 2, and that since this is an integer coming in here is going to use this conversion constructor and take in the number 2 and then convert that to an object of type y and return that. Here we pass in a string, y of some string, and that's going to use our second converting constructor, our second method of construction. Again, here's the actual call, and this is what it really is going to look like it performs. Here again we pass a 10 into y, that's an integer, so that uses this one, or object 1 equal to 10. It performs the same kind of functionality so that the number gets passed in, and then the y object is returned to object 1, and then the add of y of 5 is that's what this is equivalent to, the add sub 5, and that's our little add method over here. And we pass in 5 into y, and since we have a y object and we're creating a new one here, then our constructor runs, and since we're passing in an integer, we'll use this particular converting constructor. So a constructor is the way it's built here is always a converting constructor anyway, a constructor with a single input variable. Now let's take a look at a conversion function. So here we have an actual conversion function that is put into the class, which is created to perform specific conversion. This one is going to convert from an integer to our object. So here we have the class y, and here is the definition of operator. That's the key word there, that we have operator, and that we're creating an int operator. So that's our conversion type, and that's the return of this will be the conversion type, and it will be returning back our integer b. These conversion functions take no parameters. There's nothing that can come in because of the way they work, and because of the work that they do, they are implicitly defined to return this operator type. So we know what comes out, we know that nothing goes in. Here, the f function down here is going to take in a y object, and we're going to convert it to an integer, and that is the whole function of this conversion function. That's why it exists. So here an integer I is equal to int of the object. We know the object is y. When this int gets used here, the compiler understands to come to y and look for an operator definition, and there it is, int. So b will be returned, whatever the value of that member b is. So that will come back into I. J, here we have an int cast of the object. Casting the object to int does the same job, finds the int, returns b. And here we do an implicit conversion of I, which is an integer, being added to an object. The object has to be cast or converted to an integer, and to do that we come and look for int, find b, add them together, and put it into k. So that's our conversion function. So now we know how we can provide our own user defined conversions, and that we have to provide them when the compiler would not otherwise be able to know how to perform the conversions.